Okay, so in this video, we're going to look at how to calculate probabilities with a normal distribution. So as I concluded the last video by saying, to calculate probabilities, you need to find the area under the curve. Now, remember the curve was not very kind looking. It was quite tricky. It was 1 over sigma root 2 pi e to the negative 1/2 x minus mu over sigma all squared dx. Now, if you're asked to find the probability of less than 71, that means you need to calculate this integral. Now, by hand, you are not going to be able to do that. Calculator is going to take you forever to type in to a calculator. Instead, what we're going to do is use the inbuilt functions in our TI to calculate this for us. What I will encourage you, though, to do is draw a bell curve every time, marking in the mean, and then shade the region you want, which will give you an idea of how much you're expecting for a probability, what size. So let's do that before we have to do calculations. So we got let x be a normally distributed random variable. So x is normally distributed random variable with a mean of 75. So we always do mean. The mean goes there. And then the variance goes second, so 15, like that. So let's draw a bell curve. There's a horizontal-ish line. There's a bell curve there. Does not have to be perfect by any stretch. And you're going to mark in the mean. The mean is 75, and we're asked to find the probability of x being less than 71. So where's 71 going to be on a number line? Well, 71 is going to be less than 75. I don't know how far along it's going to be, but it's going to be down there. It says less than 71, so it must be this area here. So again, we could write out the nasty looking integral and try to find between negative infinity up to 71 there. Instead, what we're going to use is the norm CDF option on the calculator. So norm CDF, and the entries are the left bound, which is negative infinity. If you don't want to find the negative infinity button, you can just type in negative, a big number, negative 1,000 or something, and it'll work, comma, 71, and then you have the mean, 75, and the standard deviation goes in the end, which is going to be root 15, because remember the variance is 15, so the standard deviation, you square root that, and you get 15. So let's do that with our calculator. That's in menu. We're going to add a calculator, of course. So we have our menu. We're going to have probability number 5, distributions number 5, and then you have normal CDF number 2. So the lower bound has already put negative infinity in there for you, which is really nice. Upper bound was 71, the mean was 75, and the standard deviation, put the square root of 15 in here, close the brackets, press enter, and it does it for you. So you end up with 0.1509. 0.1509. Actually, we should check that to make sure that this is not being double rounded. So let's increase our float to 7. Do it again. Oop, good thing we checked that, because notice I've increased it. This 5 has come because it's rounded 9 up to 5, and then I've then extra rounded on top. If I want to round to 4 decimal places here, I only look at the 4, so it's actually going to be 1508. So always double check to make sure it hasn't been double rounded like that. Okay, let's do the next one. Okay. Probability of x being greater than 74 this time. Again, I've already got the bell curve over here, which is handy. And now what I'm going to do is mark in 74. 74 is probably there-ish. And I'm asked for bigger than 74, which is all of that this time. So x is bigger than 74. Let's do the same thing. We want our norm CDF function, but this time when we go through, I can just go up here and edit it if I want, but let's remind ourselves how we're going to do it. It's menu, 5, distributions, number 5 and number 2 again for the normal CDF. This time I want the lower bound to be 74 and the upper bound is going to be infinity. Now remember, the infinity option comes from the little button down here where the pi is. Scroll across and choose infinity. Now mu was 75. We had square root 15. You could find the square root of 15 first, but make sure you have lots of decimals and keep as many as you can. Or you could do 15 to the power of 0.5. Works in here. Hit enter. And for some reason, it didn't give me the result. Gotta love it when technology does that. So 74 up to infinity. 75 and then square root of 15. There we go, that's better. And we get 0.6019. 0.6019. Now that makes sense because the mean and up is 0.5 and 74 is a bit less than the mean, so that makes sense. Next one, find the probability of being between 68 and 77. Well, again, on our diagram over here, let's mark in 77. It's going to be a little bit bigger than 75. There it is. And 68 might be about here somewhere. We're trying to find the area in there. So the way it works, in our calculator once more, we're just going to scroll up and bring it down this time. So it's 75 and root 15 stay the same. The smallest value there was 68, goes there. And the upper value was 77, goes there. Press enter, it does it for you. So 0.6619 is your probability. That makes sense. It does look like it's probably more than half because this is very small down here. It's a long way away from 75. And then we finish off with good old conditional probability. So find the probability of this. Remember that with conditional, that means the same thing as defining the probability of it being the intersection of those two intervals divided by the probability of the second interval. Now, trying to work out the interval that is intersecting, let's draw a number line. So that'll be bigger than 70. And this will be less than 76. Look, how would you describe the section that is in common, which is, of course, this bit here is where it's in common? You would describe that as being 70 is less than x, less than 76, and divide it by the probability of being less than 76. So let's do that on our calculator. We can do it all in one go. So what I would do, it'll remove the chance of making errors. So you got 70 to 76 divided by, bring it down again, and this time we're going to have our negative infinity because that's where it's going down to. We want less than 76, and it goes to 76 there. So you can see 70 to 76, which is what I wanted here, 70 to 76. And I've got less than 76, which is the bottom one. And together, they end up giving me 0.8366. And that is how you calculate probabilities using your TI for the normal distribution.